I don't want to overlook really a very important aspect. I'm not going to be able to talk about it in great detail, although in the question perhaps we can say a little more. That is the advanced technology and in general what are known as over unity systems. In general, you know, when you talk about efficiency, you're talking about how much useful energy out do you get for the energy you put in. So in other words, for a gallon of gas that you put in your car, how much of that gallon actually turns the wheels? Well, it turns out that about 60 to 70% of that gallon just goes out the gas pipe. You know, it just heats up the atmosphere. Only about 30 to at most 40% actually turns the wheels of the car. So there's always an efficiency like that. Now, conventionally, the top efficiency is 1. How can you be more efficient than 100%? Well, what we're talking about is in over unity systems is over 100%. And in fact, ideally, the ultimate would be an efficiency, and I guess you would call it an infinite. That is to say, output without any input. That is to say, energy without fuel. Things that, you know, a car that runs without gas. Running a whole country without oil, coal, gas, or anything. Now, that third line is that the laws of thermodynamics, particularly the first law, which says you can't get perpetual motion, you can't get more out than you put in. That's forbidden by the first law. However, the first law, as it's usually calculated, does not take into account the so-called zero-point energy. Now, what is a zero-point energy? Nothing was known of that until the advent of quantum mechanics. It's now well understood. In fact, zero-point energy is where our universe was created from. You know, at the very, very beginning, at the Big Bang, there was no matter, there was no energy, there was nothing. There was only the quantum void. The only thing that was created at the Big Bang was space and time. That's all, nothing. Where did the material come from? Well, it came out of the zero-point energy, from creation of equal and opposite matter and antimatter. However, so that's where the universe was made. However, conventionally, there's no way to tap into that, says conventional engineering and physics. The ETs can tap into it, and we can tap into it. This zero-point energy, or quantum void, as it's sometimes called, in the yellow there, it's estimated that every cubic centimeter, you know, a centimeter is about ½ an inch, so it's, you know, smaller than a sugar cube. Every cubic centimeter of space has enough potential energy to run the world's energy needs for 1 day.
Zero-point energy represents about 40 to 50 megawatts of power per cubic inch of space. That's a lot of power. That's 4,600 million watts of power. And if you could tap it at will, then no one would have to sell gasoline or oil anymore. You would just tap into it. It would be like taking and going out to the Great Lakes and taking out 1 drop and using it. You'd hardly miss it.
Isn't that exciting? Do you understand that if you have unlimited free energy, you can desalinate the oceans, you can solve all the pollution problems, you can purify anything you want, you can neutralize radioactive waste, you can do just about anything you want. The barrier to doing these things is that there's not enough energy to do them. But if you have, now, even beyond that, suppose this unlimited free energy is given not just to the rich first world, but to China and South America and India and so on. Wouldn't we have a much greater leveling of economic level, and I'll say quality of life, lifestyle? Poverty is eliminated. I mean, amazing, amazing stuff. However, what does that do to the infrastructure? How about the energy companies? How about the automobiles? How about all the financial aspects of? So it's really a very fundamental thing. I've taken one example, and this is Stanley Meyer's water-powered car. There's the car. This car was driven from the East Coast to California, and it consumed a total of 58 gallons of water. No gasoline, no oil, just water. How is that possible? And whatever happened to Stanley Meyer? I have to tell you that.
They murdered him.
So you folks know about Stanley Meyer. But anyhow, there he is, died in 1998. There he is explaining how his car works. And you know, from teaching chemistry, I'm reluctant to put on this next slide, but please don't be afraid of it. But if you remember high school chemistry, this is a typical electrolysis experiment where you connect a battery to 2 electrodes and you fill test tubes with water, and as the electrons attempt to flow through this whole system, there's a break in the water. However, there's a little bit of electrolyte in the water. It might be a little bit of sulfuric acid or something like that. So even though there's not a copper wire connecting them, the current is carried by the ions that move across. And at each of those electrodes, there's a chemical reaction. And you see them written up there, and we don't even have to look at them in much detail, except just to show that on the left side, we're forming oxygen, O2, oxygen gas, and on the right side, we're forming hydrogen gas, twice as much because it's 2 hydrogens for each oxygen. If we wanted to, we could take that mixture and combine it in a fuel cell and do the reverse things, and that's how they run electricity, say on the space shuttle or space capsules. The problem with that is that it takes more electricity to electrolyze than you get back in the hydrogen and oxygen. So this is not an overunity. This is something that has a relatively low efficiency. So that's standard electrolysis. And what we're doing in that electrolysis is making hydrogen and oxygen. And we could combine them in a fuel cell to make a car go round. But we would need some source of electricity in the battery, and we wouldn't get enough back to pay for that. So we're not getting as much as we put in. Now, Stanley Meyer, this is the diagram of his patent application, and it looks a little different, but it's basically the same thing. He calls it a capacitor. That's just another way. They're actually not typical capacitors, but they're really electrodes. But so they're configured a little differently, but you have the 2 electrodes, A and B, and electric current is going one into one and then the other. The difference is Stanley Meyer, instead of using a continuous current, is using pulses. And exactly how he does it is not entirely clear, because you know the thing about a patent is that the fine art of getting patents is not to tell the whole story. Now, legally, you're supposed to reveal enough that anybody could reproduce what you're patenting. The truth is, there's always something left out, and you can't really do it just based on the patent. But nonetheless, this is the patent diagram, and the thing that he's doing differently is he's using a pulse, and he's getting over unity. Now, what he does is he's not combining these into a fuel cell. He's taking this mixture of gas and oxygen and putting it right into the cylinders and igniting them. So it's an internal combustion engine, just like a gasoline engine. It has a spark plug, they're ignited, but you're not using gasoline, you're using hydrogen and oxygen. But that hydrogen and oxygen has been produced by basically applying nothing. So that's what he's doing. This is the electrolysis unit. Stanley Meyer was contacted by people from the Pentagon, and he and his twin brother were in a restaurant, and they were discussing, the Pentagon was saying, well, we think this would be a really good way to power our tanks, and we'd like to discuss what we can do. And he drank a soft drink, and he ran out of the restaurant onto the parking lot. His twin brother ran after him, and the last words that Stanley Meyer said were, "I've been poisoned," and he died. Not unique. I simply ask you, who would be opposed to allowing a water-powered car to come on the market?